Okay, this is the introduction for Chapter 4. So far this semester we've been looking at right angles. And in this chapter, we're going to take some things that you've learned in high school geometry and what you've learned so far this semester and put them together to work with triangles that are not right triangles. So I'm going to mention a couple of things that you need to review real quick from high school geometry, and then I'm going to give you an overview of some things to come. First, you need to recall the definition of an oblique triangle. That just means that it is a triangle that is not a right triangle. And there are two types. You can see from the table here, the first type has one obtuse angle and two acute angles, or you could have a triangle that all three angles are acute. Second thing that we need to remember is that the angles of a triangle add to be 180. So if you know the measure of two angles, you can easily find the third. And also note that the longest side is opposite the longest angle, the shortest side is opposite the smallest angle. And that's a good thing to keep in mind to help you check your work. Third thing that you need to remember from high school geometry is all of these notations. In this notation down at the bottom, the side-side angle, you need to recall that that does not prove congruency, and that's going to be a special case that we're going to be looking at. And you need to remember what it means to solve a triangle. Find the measures of all the lengths and all the sides. Now we're always going to be using the standard way of labeling a triangle. The capital letters for the angles and the corresponding lowercase letter for the side opposite the angle. So you can see here with this example, I have a lowercase a that is opposite the angle that is uppercase A. And then I have a similar thing for the B's and a similar thing for the C's. Okay, here are your laws of sines and laws of cosines. And they are used to solve a triangle. Another way to say that is that the laws are used to find the measures of the sides and the angles. Now, proof of these are in your textbook. One thing I want to point out with the law of sines is this is what is on your reference sheet, but you can just easily turn these ratios upside down and get this. This second way of writing these ratios are a little bit more easy to use when you're looking for sine A because your variable is already in the numerator. This first equation is the one that is on your reference sheet for the law of cosines. The two equations below that are not on your reference sheet because your angles and your sides can just be renamed to fit this top formula. But if you would like to use all three of these and it makes it easier on you, then that's fine. Here are our guidelines to tell us when to use the law of sines and when to use the law of cosines. Now, I would not take the time to try to memorize all of this. The only one that I think that you need to memorize is the ambiguous case. So I'm going to take you through how to determine whether to use the law of sines or whether to use the law of cosines based on the information that you're given in the problem. But first we need to go back and look at the equations for the laws of sines and cosines. Notice that I have three ratios, and when you're setting up a proportion to solve, you can only use two of these ratios at a time. So let's say that we're using the first two. Notice I have 4 unknown variables in this proportion. I need to be able to substitute in 3 pieces of information in order to solve for the fourth. That means I need to know one angle-side pair. And by angle-side pair, I mean an angle and the side opposite that angle. For example, in my triangle, you can see my 3 angle-side pairs highlighted in different colors. Angle A and side A is an angle-side pair. It's the angle and the side opposite that angle. So you need to know an angle-side pair in order to use the law of sines. If you do not have an angle-side pair, you're going to use the law of cosines.